Okay, this is a quick review on how to solve systems of equations. So remember, systems of equations are when we have multiple variables, multiple equations to work with. You've learned 3 different ways to how to solve these. We're going to look at 2 of them today, all the algebraic methods. The first way is graphing. You can always graph both of these lines, find their intersection. But for this, we're going to look at substitution and elimination. So for substitution, the whole idea is that you isolate either variable in one of the equations and then plug it into the other equation. So in this case, I'm going to go ahead and isolate y. It's the easiest. So we'll change this to y equals x plus 3. Essentially, we just added x to both sides of the equation. So now that we have that expression for y, we can go to the first equation, plug it in. So now we have 3x plus 2. And with these, make sure you use parentheses whenever you are substituting in, because you need to make sure you always distribute, whether it's a number out front or a negative and so forth. So use parentheses to help yourself out. Equals 11. Whoops. So now we're just going to solve this for x. So get rid of our parentheses. 3x plus 2x plus 6 equals 11. Not a negative there. 5x plus 6 equals 11. Subtract your 6 over. 5x equals 5, and x equals 1. So that's one of our variables. Now we need to go back up. We've already solved for y in terms for x, so it's really easy just to use that expression, or you can plug x into one of the equations. Plug this in, so we get y equals 1 plus 3, and y equals 4. So our solution to this system is the ordered pair 1, 4. Our other method for solving 2 variable systems is elimination. So this is the same problem as before, just showing you a different method. So for elimination, the idea is we want to be able to add the 2 systems together and a variable will go away. So that means we need to have the same coefficient on the x's or on the y's. So I'm just going to go with the x's in this one. To turn that into a 3, we would multiply everything by 3. So now this will turn into our first equation is still 3x plus 2y equals 11. Our second equation turns into negative 3x plus 3y equals 9. So now the whole point is to eliminate a variable. So I'm going to add these 2 together. Since I have opposite signs, they'll go away. 3 plus negative 3 is 0. X. Then plus 5y equals 20. And now 0x just goes away. So we have 5y equals 20. Divide by 5. We get y equals 4. Now to solve the other variable, go back, plug back in. Again, you can use either equation. This one's just easier because there's not any coefficients involved. Plus 4 equals 3. Negative x equals negative 1. X equals 1. Same answer we got using substitution. And keep in mind, you can always check your answers with these just by plugging them into the equations, making sure you get true statements. The last method that you could use for solving is graphing these 2 lines, and if you graphed them, you would find that they intersect at the point 1, 4. If you still aren't sure on how to solve 2 variable systems, look at the textbook pages that are uploaded, Google systems of equations online. This is something you guys have been doing for the past 3 years, so this quick review should be all you need so that now you can move on to 3 variable systems.